From the moment we first looked up at the stars, humanity has sought to understand and quantify the universe.
The abacus, a simple device of beads and rods, allowed us to perform basic arithmetic.
Centuries later, visionaries like Charles Babbage dared to dream of mechanical calculators. Babbage's analytical engine, though never completed, laid the groundwork for the modern computer.
Ada Lovelace envisioned a future where computers could manipulate symbols and data, not just numbers. Lovelace became the world's first computer programmer, a testament to the power of human ingenuity.
The late 19th and early 20th centuries saw computation take a giant leap forward.
Herman Hollerith's tabulating machines, powered by punch cards, revolutionized data processing. These machines paved the way for the rise of IBM, a company that would become synonymous with computing.
The age of mechanical calculation was coming to an end. A new era, driven by electricity and the promise of even greater computational power, was about to dawn. The invention of the transistor in the mid-20th century sparked a technological revolution.
The ENIAC, one of the first electronic general-purpose computers, ushered in the era of modern computing. It was a behemoth, consuming vast amounts of power and space, but it could perform calculations at speeds unimaginable just a few years prior.
The impact of these early computers was immediate and far-reaching. NASA turned to computers to guide rockets into space and land humans on the moon.
The ability to program these machines was key to their power. Programming languages like Fortran and COBOL emerged, allowing humans to communicate with computers in a more natural way.
The world marveled at the speed and efficiency of these new machines, yet even as we celebrated our technological prowess, a new challenge was emerging. The explosion in computing power led to an unprecedented explosion in data. With each passing year, computers became faster, smaller, and more accessible.
The challenge was no longer just about processing power, it was about making sense of the ever-growing sea of data. Early databases and data storage systems struggled to keep up with the deluge.
Relational databases emerged as a solution, providing a structured way to organize and query data. New programming languages like SQL were developed specifically for managing and querying these databases.
The sheer volume of data began to overwhelm traditional analytical methods. Statistics, once a powerful tool for extracting insights from data, struggled to keep up.
What was needed was a way to automate the process of finding patterns, making predictions, and extracting knowledge from this vast digital ocean. Little did we know, the seeds of a solution were already being planted in a field that seemed, at the time, more like science fiction than science fact: artificial intelligence. The dream of creating machines that could think like humans is as old as the idea of machines themselves. The dream of thinking machines?
In 1956, a group of visionary scientists gathered at Dartmouth College for a workshop that would mark the birth of AI as a distinct field of study. Their goal was ambitious: to create machines that could simulate human intelligence.
Early AI research focused on symbolic reasoning, logic, and problem-solving.
Alan Turing proposed a test to determine if a machine could exhibit intelligent behavior equivalent to, or indistinguishable from, that of a human. The Turing test became a benchmark for AI researchers, though it remains controversial to this day.
Despite early enthusiasm, progress in AI proved to be much more challenging than initially anticipated. The limitations of early computers, combined with the complexity of human intelligence, led to what became known as the AI winters. Winters of discontent. The history of AI is not one of steady progress, but rather one of cycles of hype and disillusionment.
Twice, in the 1970s and again in the 1980s, the field experienced periods of reduced funding and interest, known as AI winters. These winters were brought on by a combination of factors, including unfulfilled promises, limited computing power, and a lack of data to train sophisticated AI models.
The first AI winter was triggered in part by the limitations of early AI systems. These systems, often based on symbolic reasoning, struggled to handle the ambiguity and complexity of real-world problems.
Funding for AI research dwindled as researchers struggled to overcome these limitations. The failure of expert systems to live up to their hype led to another wave of disillusionment and a decline in funding for AI research.
The AI Renaissance. Despite the setbacks of the AI winters, Research continued in various labs and universities around the world.
In the late 1990s and early 2000s, a confluence of factors converged to spark an AI renaissance. Advances in computer hardware, particularly the development of faster processors and cheaper memory, provided the computational horsepower needed to train more complex AI models. The rise of the internet and the proliferation of digital devices led to an explosion of data, providing the raw material that AI algorithms crave.
New algorithms like deep learning emerged, inspired by the structure and function of the human brain. The success of deep learning in these areas reignited interest in AI, attracting significant investment from both industry and academia. A future forged by AI. Today, AI is no longer a futuristic fantasy. It is rapidly becoming an integral part of our daily lives.
In healthcare, AI is being used to develop new drugs, diagnose diseases earlier and with greater accuracy, and personalize treatment plans. Self-driving cars, powered by AI, promise to revolutionize transportation, making our roads safer and more efficient.
In the realm of big data, AI is helping us to make sense of the vast amounts of information being generated every day. From predicting consumer behavior to identifying fraudulent transactions, AI is providing businesses with insights that were previously hidden within mountains of data.
AI is also being used to address some of the world's most pressing challenges, such as climate change and energy sustainability. From optimizing energy grids to developing new renewable energy sources, AI is playing a crucial role in creating a more sustainable future.
As we look to the future, the potential of AI seems limitless. AI-powered robots are already working alongside humans in factories and warehouses, increasing efficiency and productivity. The future forged by AI is one that we will create together, and it is up to us to ensure that it is a future worthy of our dreams.